Okay. Are we still on YouTube? Okay. Okay. Good afternoon, everybody. Meteorologist Blake Matthews here. It is class number 5 in our weather school series that we're doing here while the kiddos are on an extended break as we continue to deal with the coronavirus and social distancing. So today's topic is going to be on something that kind of interests me quite a bit, especially growing up here in the Houston area, and that is tropical storms and hurricanes. This area has a very long and storied past when it comes to both. We've had devastating tropical storms, we've had devastating hurricanes, one of which happened not long ago, 3 years, when Hurricane Harvey hit the Texas coast as one of the strongest storms ever known to hit this state. Again, that was category 4 in the central and south Texas coast. We're going to talk about it all. We're going to talk about our vulnerabilities, where these things develop, where they often head to, and of course how you can prepare for a tropical storm or hurricane if one were to head this way, God forbid, in the 2020 season. All right, let's start off here with graphic number 1. We're going to be talking hurricanes and tropical storms, where and when they develop, and a look back at our violent past. So, the countdown to the hurricane season. We are just 69 days away now from the start of the hurricane season. Does anybody know when the tropical storm hurricane season begins? Anybody? Anybody? In fact, while you guys are throwing out guesses, I am going to get on my phone and pull up our K2U Facebook page. That way I can see your questions as they come through. So the answer to that is, oh, there we go. Look at that. I could see myself right there. So the answer is June 1st. So any of you answered June 1st, you would be correct. 69 days away. Of course, I guess it's right there on the graphic. Hey, you know, it's a good thing it wasn't a snake, right? All right. So when we're talking about the hurricane season, as we go into next month, we've got a series of forecasts that are going to be coming out from different research areas and from the government itself. And one of the ones that we watch for the most is the one from Colorado State University, which is really strange because what in the heck does a bunch of people in Colorado know about a hurricane, right? They should be talking about blizzards and avalanches and wildfires and things like that. No, Colorado State University, a very well-renowned school when it comes to tropical forecasting. Of course, the late Dr. William Gray was famous for his forecasts, and now Dr. Klotzbach has taken over, and he is the one that is issuing the forecast. So you'll see a bunch of question marks right there. Colorado State University expected to put out their forecast coming up in early April. So in about a week and a half, we should get our first peek as to what we can see, what we could see in the upcoming hurricane season. You'll see right there that I put likely very active. A very active hurricane season likely, and the reason for that is because we are looking at ENSO, which is basically an El Nino, La Nina type event that could or that may or may not take place in the Western Pacific. So right now indications are that we could be in a neutral and or a light La Nina pattern, which transitions to a very active hurricane season in the Atlantic Basin. So El Ninos produce a very inactive season in the Atlantic and a very active Pacific, while the La Nina conditions produce a very active Atlantic and a very quiet Pacific. So it is a reverse relationship there. So we will have our first look at what we can expect in the upcoming storm season coming up in about a week and a half. The normal amount of storms that we see is 12, 6.5 hurricanes and category 3 or higher. Well, we see on average 2 of those. And of course, I know some of you saying, how can you have a 6.5 hurricane? Well, you can't. It's just an average. But 6 to 8 generally is a pretty good number. Now, here's a look at the storm names that are anticipated for the 2020 season. We've got Arthur, we've got Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, all the way down the list, all the way down to Wilfred. We've only reached the W storm one time. Anybody know what year that was? Well, that was a very, very active season, obviously, back in 2005. We had Hurricane Wilma, category 3. Actually, Wilma powered up to a Category 5 hurricane, one of the strongest hurricanes ever observed in the Atlantic Basin, with winds of 185 miles an hour. Thankfully weakening before it hit the U.S., moving across southwest Florida near Sarasota and across the Florida Peninsula as a Category 3 hurricane. And that was the year we also used the Greek alphabet: alpha, beta, gamma, delta, zeta, epsilon, and so on and so forth. So we got pretty long that year. In fact, the hurricane season lasted all the way into January, if my memory serves me correctly. So that's pretty unusual. Hopefully we don't get too deep into the storm season this year, but certainly something you're going to want to always be prepared for. Now, the season begins on June 1st and ends on November 30th. That's a pretty arbitrary range there, because we have seen storms develop in April. Actually, not too far back. I believe it was subtropical storm Andrea, if I remember correctly, formed in the month of April a few years ago. So they can happen. We have seen storms and hurricanes in the month of May. We've also seen tropical storms and hurricanes in December. So they can form on either side of the season, but the vast majority, 99% of all storms that we see, do form between June 1st and November the 30th. Now, here in the state of Texas, our storm season, yes, we do get tropical storms, and we have had hurricanes hit Texas in June and July, but really our storm season, when we really have to be on guard, is going to be August and September. And it's really that block of time, those 2 months, is really when we face the most dire situations as far as strong hurricanes and tropical threats go. The reason why we don't worry too much when we get into October and November, because they don't hit Texas in October and November. They have. In fact, we had Hurricane Jerry in 1989 hit the Galveston area as a Category 1 hurricane, but that is an exceedingly rare event. Anybody know why hurricanes would be exceedingly rare here in the state of Texas in October and November? Anybody? In fact, I'm going to start reading off some comments here and take a look at some of the guesses. The reason why is because you get cold fronts that begin to work their way off the Texas coast as you get towards the end of September and into early parts of October. So you think back to Hurricane Ike that hit on September the 13th, 2008. Ike was picked up. The reason why the eye of Ike did not move directly over downtown Houston, if you remember correctly, Ike came right in over Galveston Island and then hooked ever so slightly off to the right. It began to jog to the right, and that was because of an approaching cold front that came through. And if you remember correctly, back in the night of after Ike, so Ike came through very early in the morning, and then that night and the succeeding nights after that, temperatures were in the 50s overnight. It was extremely comfortable. In fact, Ike pretty much put an end to the summer here along the upper Texas coast. So you start getting into the middle and latter parts of September, and you start seeing these fronts move through, and they act as big brooms to push everything on off to the east. Another very famous example, of course, is Hurricane Rita. If you weren't here in September of 2005, well, Rita was a very powerful Category 5 hurricane that powered up in the central Gulf of Mexico, at the time the most powerful hurricane ever observed in the Gulf of Mexico. And Houston was dead center of the cone. In fact, if you remember the widespread evacuation, the entire city, almost the entire city left. We're talking 3 million of 5 million inhabitants at the time, jammed the freeways, and of course the travel times to Dallas, 48 hours, 36 hours to Austin, 30 hours to San Antonio. And guess what happened? Rita missed. Rita hit Beaumont and Port Arthur out towards the Louisiana-Texas state line. And the reason why it missed is because of a cold front. So you start getting into the late September timeframe, into early October and November. And in order to get a tropical storm and hurricane into the Texas coast, either A, it has to develop very close to the coast, or the timing just has to be absolutely immaculate to hit in between cold fronts. So they don't happen very often. So that was a very long-winded answer to say our storm season in Texas, June to September, but really the peak is going to be August and September. That's when we really have to be on guard. Okay, so one of the things that powers up hurricanes, and the reason why that season really is in the middle and the latter part of summer, is because of sea surface temperatures have to be at least 80 degrees or warmer to a depth of 150 feet. So This is a look back, I believe, from 2018, I believe, and you can see we were dealing with very cool SSTs, sea surface temperatures, and we monitor this because if the Atlantic starts showing up cooler than average, then that could suppress hurricane development. So hurricanes are giant heat engines, and keep in mind that the whole point of weather on the planet is to redistribute heat, right? So weather, the whole point of having weather, whether it's a tornado or a hurricane or any kind of weather phenomenon, is to balance the planet. But the planet can never have equilibrium because we are tilted at 23.5 degrees on our axis, and therefore we have differential heating around the planet. In the summertime, the northern hemisphere gets hotter than the southern hemisphere, which causes a pressure difference, and therefore that causes wind. Wind moves weather patterns around, and it's very difficult. In fact, it's absolutely impossible to get equilibrium, and that's why we have weather. So these hurricanes are giant heat engines. They thrive on the latent heat coming out of the Atlantic, Pacific, Indian, and all the ocean basins around the world. And these giant heat engines, they power up near the equator, and then what happens? They hook north and then dissipate when they get to the higher latitudes. That is Earth's way of redistributing the heat around the planet. So a little FYI there, a little tidbit for you. As these things are as ferocious as they are, they're absolutely necessary in order for us to be viable on this planet. So that's one of the things that we watch for is sea surface temperatures. Remember, 80 degrees or warmer to a depth of 150 feet. The other thing that we watch for is the Madden-Julian oscillation. This is what we call the MJO, and this is important as well. The MJO is a propagating wave of low pressure around the globe, constantly moving the same direction, east to west, or west to east, and as this MJO pattern begins to move into a certain phase, what we call phases 1 and 8. It's getting very deep here. Now, it's something that would require a whole nother lesson in and of itself. But when the MJO gets into phases 1 and 8, it means that there is a lot of disturbed weather, a lot of uplift in the atmosphere, a lot of areas of low pressure, and those low pressures are what end up developing into tropical storms and hurricanes. So when we see the MJO, this propagating wave of low pressure, move around the globe, and it gets into a favorable phase for Atlantic development, phases 1 and 8, that triggers to us, that tells us that we need to be on a heightened sense of alert on any tropical wave that could be propagating through the Atlantic, because there is a better chance that that could develop than if the MJO was on the other side of the planet, say in the Pacific. So the Madden-Julian oscillation is something that we watch very closely, especially when we get to the summertime. So remember, I was talking about the Texas hurricane season, that yes, we do get tropical storms and hurricanes to hit in June. We get them to hit in July, August, and September. But this is really going to illustrate my point perfectly, that the storm season really for Texas is August and September. Here's a look at June and July hurricanes only. I did not put the tropical storms on here, which by the way could be equally as devastating as we saw during Tropical Storm Allison. And last year we had Tropical Storm Imelda that put a lot of water into the Houston area as well. So if you take a look at June and July there, all the yellow lines are going to be category. Well, it looks like the color scale is a little off there. So don't pay attention to the color scale. That's clearly not correct. But the June and July hurricanes you see in the yellow are going to be basically less than category 3. We're talking categories 1s and 2, mainly just 1s. And we've got one stronger hurricane there hitting the Brownsville area. So going back, this is since 1900, so in 120 years we've had 6 hurricanes hit the state of Texas. So clearly, you average that out, doesn't happen very often. So yes, we can get tropical storms and hurricanes in June, but they're not very likely. Couple that with August and September, and now all of a sudden you've got a whole lot more. We've got category 3, 4s, and 5s all hitting the state of Texas. Here locally, some of the strong storms that have hit include Hurricane Carla, September the 11th, 1961, category 4, arguably the strongest hurricane to ever hit the state of Texas. It was a category 5 just off the coast of Matagorda. Hurricane Alicia, August 18th, 1983, Category 3, known for tremendous glass damage and tree damage in the Houston area. We've got the 1900 storm that hit on September the 8th, 1900. We had the 1915 hurricane hit Galveston 15 years after the 1900 storm. The 1900 storm killing 8,000 to 12,000 people, but after that storm they built a seawall, and when a storm of equal strength hit the island of Galveston 15 years later, the death toll was only 400. So the seawall certainly paying dividends there as far as saving lives. So we've got Carla, Alicia, Rita, of course, causing the big evacuation here back in 2005, Hurricane Ike, September 13th, 2008. And the list could go on and on, but those are some of the big ones that have hit in the months of August and September. Here's my point. Now you get to October and November. Remember, what is the reason why that we don't see hurricanes and tropical storms very often? Cold fronts. At this time, strong cold fronts are moving through the state. And you can see that you can count on 3 fingers the amount of hurricanes that we have had hit the state of Texas in the month of in the month of October and November, the last one being Hurricane Jerry in 1989. One of the more famous ones, we spoke about this yesterday, Hurricane Alicia. There's a satellite image of it on the morning of August 18th, 1983. This was a Category 3 hurricane. Alicia, a very interesting storm developing within 48 to 72 hours just from a little batch of thunderstorms out over the open Gulf of Mexico, rapidly intensifying and moving directly into Houston, Galveston on the morning of August 18th. Now this is pretty much a worst case scenario given our huge population here in Southeast Texas. Harris County, this one county, 5.5 million people. It's the second, I believe, most populous county in the entire United States. So when you have a hurricane, especially a strong one that's developing, can cause big problems for city and emergency planners to get people out of the way in time. So that is something you definitely don't want to see. So you can see the very short path forming just south of New Orleans and quickly making a beeline for the upper Texas coast. We had a wind gust in Galveston of 126 miles an hour on the Coast Guard cutter Buttonwood there moored in Galveston. It does not have to be a busy season to be a devastating season. Hurricane Alicia was one of just 4 storms that formed in 1983. And it was the strongest and causing the most damage. In fact, it was Texas's first billion-dollar storm. There's a look at the Wells Fargo Center, back then known as the Allied Bank Center. It is the second tallest building in Houston, and it's the second tallest building in the United States. And clearly the amount of glass damage was tremendous to this building, partly because the rooftops back then were made of gravel, and of course when you have winds howling at over 100 miles an hour, those little pebbles become like a shooting gallery, and we lost thousands and thousands of windows through the downtown Houston area. So let's talk some superlatives here. The strongest hurricane ever to hit the United States was the Labor Day hurricane of 1935. Winds in excess of 200 miles an hour moving through the Keys of Florida. Pressure at landfall 892 millibars. Now we measure hurricanes by the pressure. The lower the pressure goes, the stronger a storm is. And the average sea surface pressure, like if you were to walk outside your door right now, you would be experiencing a sort of a cloudy day out there, maybe 1,000 millibars, 1,005 millibars. Now imagine a pressure of 892 millibars, and folks, that is a very, very bad day. Clearly killed quite a few people there in the Florida Keys. Winds again gusting well over 200 miles an hour. The deadliest hurricane goes to the 1900 storm in Galveston. Of course, Houston back then was just a very small town. About 43,000 people, I believe I read, lived in the Houston area at that time. Galveston was known as the Wall Street of the Southwest at the time. It was by far the richest city in Texas, one of the richest cities in the entire country. It was the city of first opera house, first library, first newspaper, first city with electric trams, first city with electric lights. It was truly the New York City of the South at the time. and certainly would have overshadowed many of the great cities along the Gulf Coast today. In fact, had the 1900 storm not hit Galveston, it would likely be the epicenter of the population today, and Houston might be just a little suburb, who knows. But the Great Galveston hurricane certainly changed the history of Southeast Texas, especially when you lose 6,000 to 12,000 people in one night. Most people drown. It was a tremendous storm surge. Remember, Galveston is just a little tiny sandbar, only a few feet above sea level, and you have a very shallow slope out there over the Gulf of Mexico, so you could walk way out into the water and not really be in over your head. That shallow slope of the coast aided in a tremendous storm surge. Of course, we did not have the satellite technology back then that we do today. Nobody saw the storm coming. In fact, many of the residents of Galveston at the time were amazed at the tremendous waves that were crashing along the beach that morning on September the 8th, 1900. And the chief meteorologist at the time, Isaac Klein, had no idea the storm was coming either. What's interesting about him is that a few years back he wrote a letter to the Galveston Daily News saying that it would be a grand illusion to build such a thing as a seawall, something that the city of Galveston wanted in the late 1800s after the destruction of Indianola down the coast back in 1886. What's interesting, the meteorologist Isaac Klein said not only is it a grand illusion to build a seawall, but a hurricane could never hit Galveston. He believed. Said that the waters were too shallow for a storm of great strength to hit Galveston, and unfortunately he would be proven very wrong just a few years later. So that is the deadliest hurricane in U.S. history by far, and the costliest is Hurricane Katrina back in August of 2005. $125 billion in damage, Category 3, tremendous storm surge overwhelming the levees there in New Orleans. And Hurricane Harvey, by the way, very close to overtaking Katrina as the costliest. Hurricane Harvey is a very close second place as far as the most costly hurricane. There's a look at one of the pictures there in Galveston. Obviously, the city totally wiped off the map, essentially just a few buildings remaining. If you go to Galveston today, you look for the little plaques next to the door. Only about 100 or so exist there on the island. Very few buildings survived. Many of them, of course, were wood structures, and this tremendous storm surge that came in wiped many of them away. There's a picture of the Indianola hurricane, August 20th, 1886. It literally removed Indianola off the map, and that town no longer exists. In fact, if you go to Matagorda County, there's just a little tiny plaque there indicating that there was once a town that thrived there on Matagorda Bay. Tropical Storm Allison, we do get tropical storms here. They are equally as big of a threat due to the amount of rainwater that they can produce. 35 to 40 inches of rain there in Tropical Storm Allison, paying not one but two visits there to the upper Texas coast. There's a look at the rain tallies. You'll notice that little bullseye there in the green. That is 35 inches of rain. And what I want to point out here is I'm using the exact same color table. Okay? Notice the green, 35 inches. You ready? That's Harvey. 50 to 60 inches of rain in Hurricane Harvey, something that has never ever been seen. So another thing that we monitor when it comes to development of tropical storms and hurricanes is, as ferocious as these storms are, they're also very, very delicate. They require very perfect conditions to develop. They're very needy, very demanding, and they require things to go their way in order for them to develop. And one of the things that we watch for is what we call wind shear. Of course, the higher up into the atmosphere you go, the stronger those winds are, because you get away from the frictional forces of the surface. Now, this particular map that you're seeing here is showing something, is showing the wind shear over the continental United States right now. You can see the jet stream cutting through Colorado, Kansas, Missouri, and down into the southeast. But you look over the Gulf of Mexico, and we've got a nice ridge of high pressure out there. So actually the conditions in the Gulf of Mexico right now, especially in the southwestern Gulf of Mexico, would actually be pretty good for development, because you don't have strong wind shear ripping the tops of thunderstorms off and tilting the storm. So basically, hurricanes have to be completely vertical. You get that wind shear, those thunderstorms get tilted, and the tops of the thunderstorms continuously get blown away, and tropical storms and hurricanes cannot develop. There is a look at Hurricane Harvey on final approach to the Texas coast. At this time, it was approaching Category 4 strength, one of the stronger hurricanes to ever hit the Texas coast, certainly in my lifetime. And that was a very, very bad morning. That is Chief Meteorologist David Paul there. Snapped a picture of him. Now, of course, many of us are familiar with the cone, but you know, forecasts are getting really, really good. We've got some very good computer models. Of course, the European model, the gold standard when it comes to hurricane forecasting. If you look back at the cone from 2008, in the orange, you can see how wide it was, basically from the central Florida peninsula all the way almost to the Texas state line. And as of 2018, that cone has shrunk considerably down to about 2/3 of the original size. So forecasts are getting better and better, especially the further out in time we go. But keep in mind that the cone represents where the eye is expected to pass within about 66% of the time. Now, a third of that, 33% of the time, the eye will pass outside the cone. So a cone is a good representation as to where the eye may pass, but a third of the time, 33%, the eye will end up outside the cone. So it's always good to keep a very close eye on the forecast at least twice a day when a hurricane is threatening our area. Another reason why that hurricane forecasting has gotten so good is because the amount of hurricane missions that are flown in hurricanes. We've got NOAA that flies Orion aircraft into the storm. They fly very high altitudes in a ring formation all the way around, sampling the atmosphere ahead of the storm to see what kind of conditions are the hurricane is going to be encountering over the next 24 to 48 hours. And then, of course, we have what happened to my other graphic? Oh, it looks like I put the same graphic in here twice, so my apologies on that. The other airplane that we fly is the Air Force flies directly into the eye of the hurricane, and they're the ones that are taking exact measurements of the eye. They're taking the eye temperature, because the warmer the eye is, the stronger the storm is likely to be, because remember, air as it goes up through a hurricane, it goes right down through the middle, and as the air compresses in the eye, it warms, and as the air is going down, nothing can go up and the eye clears out. That's the reason why the weather is very nice in the eye of a hurricane, is because, well, there's no rising motion. It's very calm, and if all the air is being compressed, it can't rise. If the air can't rise, it can't cool. If it can't cool, it can't condense, and therefore no clouds and no rain can form. So that's the reason why the eye is nice and clear and is calm, because the air is sinking in the eye, and if you compress a gas, any type of gas, it warms. So that's why they're taking the temperature of the eye. They're looking at the diameter of the eye, because we know that what's the law? I can't think of it right off. Conservation of angular momentum suggests that the smaller you get something, the faster it will rotate in, which is why when an ice skater has her arms way out, she spins very slowly, but as she brings her arms in, she begins to spin very, very rapidly. And the same thing happens in a hurricane. The smaller that eye gets, the faster those winds go near the center. And same thing works in any area of low pressure, including a tornado. And the reason why tornadoes are so strong is because it's a hurricane over a very small scale with very, very deep pressure depressions, and that's the reason why a tornado has extremely strong winds, because the pressure gets very low over a very small area. And remember, the tighter that gets, the faster those winds go. And clearly a tornado is much, much smaller than a hurricane. So if we do have a hurricane threatening the upper Texas coast, one of the first things you're going to want to grab, of course, is water. You're going to want 1 gallon per person for at least 5 days. Food, diapers, protein bars, anything that's non-perishable. You're going to want medicines, pet food, etc. Batteries, flashlights. Don't forget, you're going to want a basic first aid, band-aids, tape, rubbing alcohol, tweezers. And a lot of people forget manual can openers. You're going to want one of those as well, because we're likely not going to have electricity for a long time. In fact, during Hurricane Ike, we were without power for 11 days, and that wasn't nearly as long as some of us experienced across the Houston area. Of course, we know in the middle of August and September, mosquitoes can be extremely bad. Anything that is deep based will be really good at keeping those little boogers away. Of course, you want to avoid the chaos as much as possible as well. So one of the things you're going to want to do, of course, not only listen to Channel 11 for the weather information and what you'll need to do to get yourself and your families ready, but you're going to want to listen to local and state officials. They are the ones that issue evacuation orders. If an evacuation is issued, you're going to want to heed that immediately. It's done by zip zone. And we've got coastal zip zones, we've got zip zones A, B, and C, all broken down by your zip code. And of course, if your zip code is called, you're going to want to get out as soon as possible, because as we saw in 2005, even people that do not live in evacuation zones often get caught up in the chaos, they get scared, and the freeways become pretty impassable pretty quickly. So I think that is the end of my PowerPoint session. I thought if you give me just 1 second here, I may actually be able to show you the zip zones themselves, but it looks like my computer is having a little bit of an issue, so we'll give that a second to catch up. And in the meantime, I'll see if I can take some questions. Erica, thank you, fifth grader. Thank you so much for your question. She asked, can a hurricane and a tornado form at the exact same time? Oh, you bet they can. In fact, during Hurricane Harvey and Hurricane Alicia, both of which were prolific tornado producers. In fact, we had over 100 tornado warnings issued at the height of Hurricane Harvey. And tornadoes actually are responsible for quite a bit of damage that hurricanes actually ultimately end up doing. So yes, tornadoes and hurricanes absolutely can produce tornadoes. Hurricanes can produce tornadoes while they are ongoing. And oftentimes these tornadoes are small, but they're intense, and they don't show up well on radar. So they often hit by surprise. And that's why it's important at the height of a hurricane to stay away from windows. Of course, not only can the hurricane blow out your windows, but you can get these little tornadoes, these little mini vortices as we call them, to spin up very rapidly, and they can often hit many times without warning. Reshma, fifth grader, she wants to know, how long does a hurricane last and how do hurricanes end? And well, hurricanes can last a very, very long time. They can last a month or more if they're out over open water in the Atlantic or the Pacific. And of course, if they hit land, they begin to slow down. And the reason why is because land does not have the heat capacity that water does. Remember, hurricanes are heat engines, and they thrive off of the latent heat coming off the Atlantic or Pacific or Indian Oceans. And as long as they have that water source, that energy source, the hurricane will continue to thrive, assuming that the upper level atmosphere is also conducive. Remember, they're very, very fragile. For as ferocious as they are, they're extremely fragile, and they require perfect conditions. So it's a multi-layered cake here. You have to have the warm sea surface temperatures. You have to have the atmosphere above to be completely quiet as far as wind shear goes. It can't have a lot of strong wind shear, because you'll tilt the hurricane and the thing kind of begins to unravel. The other thing is hurricanes have to continue to move. And the reason why is because if the hurricane sits over the same spot, if they stall out like Dorian did last year, they begin to create something called upwelling. And the upwelling is the hurricane is churning up the water. It's churning up the water. And guess what happens when you turn the water up? Cool water from deep down begins to rise up to the surface. Not to mention it's rain contaminated on top, because rain is pretty cold, right? And it begins to cool the sea surface temperatures. Well, guess what happens when you cool the sea surface temperature down below 80 degrees? The hurricanes begin to choke a little bit, and then they begin to slow down. So that's one way hurricanes can break up. They can run into high wind shear, they can run into colder water, and or they begin to run over land where frictional forces from the land, trees, buildings, the ground itself begin to slow that wind down, and the hurricane begins to dissipate. So that's a really great question. Thank you so much for asking. Erica, another fifth grader, says, can there be lightning during a tornado? Oh, very much so. Lightning, for sure during a tornado. But you know, interestingly enough, hurricanes really don't produce much lightning at all. Very, very little. And the reason why is because hurricanes are warm core systems. Now, what does that mean? Well, normally, like dealing with a tornado, you have a very warm atmosphere at the bottom and you have a very cold atmosphere up top, and that produces a lot of rising motion because that warm air, as long as the air is colder aloft, it's going to keep rising. Well, the higher it rises, the colder it gets, the more it condenses, and hail begins to form, right? So that's why they always say that, hey, a green sky is usually a precursor of a tornado. Well, what causes the green sky is the hail refraction. So you have a lot of hail in the cloud, the sunlight is coming in through the cloud, it hits the ice, and the color green is scattered. So when we see a green cloud, we know right away that it is full of hail. If a storm is strong enough to produce hail, it can be strong enough to produce a tornado. So yes, they often do produce lightning. Hurricanes, however, are warm core from bottom to top, and it's very difficult to get ice to develop in a hurricane. And if there's no ice, then the charges, as the ice bumps into each other in the cloud, cannot knock off charges, and if there's no charge difference in the cloud, then there can be no discharge of static electricity, which of course we see as lightning. So lightning is very, very rare in a hurricane. So yes, tornadoes produce lots of lightning, hurricanes do not. Let's see. So Rachel wants to know, what is the smallest hurricane? Well, it's interesting. In the Atlantic Basin, it happened a few years ago, and it was, I believe, Marco was a Category 1 hurricane in the southern Gulf of Mexico, and it was extremely tiny. Let me see, I believe it was Marco, I'm going to look it up. Tropical storm Marco, and it only had a diameter of like 40 miles, and it was very, very tiny. Let me see what the diameter was. It does not say, but probably not much bigger than Harris County. It was extremely small, forming back in 2008 in the southwest Gulf of Mexico. You can take a look at yourself. It was Tropical Storm Marco in 2008, and I wish it gave the diameters, the dimensions. Tropical storm force winds extended out only 11 miles. So that is pretty tiny. The largest hurricane on record, by the way, is Typhoon Tip, and that occurred out in the Pacific back in the 1970s. And if you were to compare the two, if you were to put Tip over the United States, it would stretch from the East Coast all the way out to Denver, Colorado. So it was absolutely massive, taking up many, many states. And that was also one of the strongest storms on record as well. The difference, by the way, of a hurricane and tropical storm, or a hurricane, typhoon, and a cyclone, as they're called in the South Pacific, is just the geography, where they're located. Hurricanes in the Pacific Ocean and the Western Pacific are called typhoons. If they're in the Eastern Pacific, they're called hurricanes. If they're in the Atlantic, they're called hurricanes. If they're in the South Pacific, they're called cyclones, or as the Australians call them, willy willies. I'm not making that up. All right, let's see. Tawny McHenry wants to know, she's 8 years old, has a hurricane ever covered up the entire state of Texas? I don't know about covered up the entire state of Texas, but we've had hurricanes in the Gulf of Mexico the size of Texas. Many of them, actually. Katrina was one, Ike was one, Hurricane Allen in 1980 was also a